position something, isn't it? So at a certain place. If without that, why do we even need coordinates for? We need a coordinate to be able to measure, really. Yes, you can't measure distances if you don't have coordinates. Is okay. So a lot of measuring instruments, apart from the ruler, and we realize that the ruler is really limited. Are you okay? In what it can do. So we can also measure just coordinates and get to know the distance between 2 points. Let's understand that. Coordinates go beyond just X and Y. We can talk about the Z as well. Are you okay? So triplets of numbers measuring horizontal and vertical distances. Really, coordinates are distances. That's another thing we should know. Coordinates are distances. Are you okay? And it's very important to also know that there's the origin and other coordinate systems. So we can talk a little bit more on coordinate systems under map projection, which is one of the things we'll be touching on in this class. A very simple formula, it can be used to always compute the distance between 2 points. In GIS, we need to know these basic things. Okay, we need to know some basics. All right, so that is basically it on distances. The next thing we also want to talk about is the data sources for GIS. So data sources start with surveying. What do surveyors do? On a daily basis, surveyors use their instruments to measure angles, distances. Is that not so? And then these angles and distances are then used to do what? Compute volumes, okay, to determine ownership of property and a whole lot. Okay. All right. So surveying is a very popular, method that has been used over years. Okay, to just determine the terrestrial three-dimensional position of points and distances and angles, etc. Is that okay? And every surveyor, that's just that one thing, measuring to obtain these coordinates. The rest, you can go to the office and then get it done. Okay, but the actual surveying process, require that you measure distances, angles as well. Okay, all right, I also measured. All right, so let's carry on. Surveyors, land surveying is the detailed. Let's look at another definition of surveying. It's a detailed study or inspection by gathering information through observations, measurements in the field, questionnaires, blah, blah, blah. Okay, all that becomes a source to GIS. Okay, data source, it's a primary data source to GIS. I'm not really saying primary and secondary, but you should know that collecting data on the ground directly, is actually a primary, data source that you are really referring to when you do that. Okay, so we all know that this is not all about surveying, but obviously precision measurements are done. So surveyors just don't measure, anyhow. They always make sure that they've done what we call an accurate measurement or precise measurement. Are you okay? All right. Lengths, angles, elevations, then later on areas and volumes can be calculated. Are you okay? They make use of control points. There's another data source, primary data source, also called the photogrammetry. This one may not be familiar to a lot of people, but yes, you can fly over an area and take pictures, and that's enough for you to actually obtain the three-dimensional coordinates for almost every object that appeared in the photograph. So that is called photogrammetry or aerial photogrammetry. Okay, we are saying it's a technique for creating two-dimensional or three-dimensional models. So the thing with photogrammetry is that you can obtain the coordinate, the three-dimensional coordinates of points, okay, within a certain common overlap region. Is that okay? Which is about 60%. So you take photographs that overlap and that allow you to generate a 3D model. Are you okay? So one of the outputs of photogrammetry is actually the digital elevation model. Is that okay? The platform used is always a helicopter, biplane. You can use a drone as well. Okay, a drone can be used, but normally there's a camera or some kind of sensor which is mounted under it, the platform. that looks down vertically. Okay, so we have vertical photographs are normally used, and then we take, successive photographs along a flight line. Okay, and we cover a large area with a block of photos, and then we are then able to map the whole area. Most of the time you use photogrammetry for accident, area when there's been an accident or something like that, where you cannot go there to go and set up an instrument and measure. You can just fly and then take a picture. So I'm not talking about just a car knocking someone down. I mean, you're talking about accidents that span larger areas. Okay, if you want to quickly map and ascertain the damage done, you can do that. Is that okay? Just that we don't see a lot of this happening in Africa. Okay, we see a lot of this in movies, isn't it? All right. So now let's actually look at it. Okay, I've already talked about, yeah, let's look at what we haven't touched on. Overlapping, non-overlapping photographs can be used. Okay, then the model can be 2D or 3D. Okay, all right. We can generate what we call the auto photographs. Okay, normally we don't want the photo to be tilted, so the camera has to hang vertically over the area. So we always want to get rid of tilts of the camera. And then also, if the area has a lot of, undulation, which we also call relief, we also want to get rid of that. Okay, we make use of ground control points, okay, which can be established prior to the flight. Okay, so we do what we call pre-marking. You fly over the area so that you can actually associate coordinates with all the objects within the area of interest. And then one of the things you generate is a digital elevation data. Is that okay? Which is very interesting, very powerful. So for gaming and for simulations, you can use that data, and it's gonna really help you. Are you okay? All right. So that is photogrammetry. For the final product of photogrammetry survey can be an input into GIS as an image background. Because you are obtaining photographs, that photograph then becomes a raster data set. So as I said, we talk about raster. But yes, so we can just, through photogrammetry, we can always provide a background data in GIS as a layer. So we can put it in as a layer. We just talked about layers, guys. I hope you remember. Okay. And that is a good reference over which a vector layer can be overlaid. So we can put in some vector layer, overlay it, look at it, think with it. The whole idea of GIS is to support the decision making that you have to do. It can be digitized. You have a picture, you can digitize the picture in what we call on-screen digitizing. Is that okay? All right. So that is photogrammetry for you. I've just touched on land surveying, which makes use of theodolites, okay? And surveyors use land surveying to do that. I've just touched on photogrammetry, which makes use of airplanes flying over and taking pictures, and then generating three-dimensional coordinates. Is that okay? The pictures which can be very useful as a background layer to GIS. The pictures which can be digitized, are you okay? So that we extract vector data from that raster data in what we call the vectorization. Is that okay? And so now I want to touch on another important, I think we all heard of GPS. It's in our phones. It's in my phone right now as I'm speaking to you. It's lying, my phone is lying beside me right now. The GPS is right there. It's also in your phone lying in front of you. If you see location on your phone, then you likely have what we call the GPS receiver inbuilt into your device. Is that okay? All right. So the actual full name of GPS is Global Positioning Systems. Global Positioning Systems. Is that okay? And it's a navigation and precise positioning tool. It's a navigation. Why? So the GPS actually developed by the US Department of Defense, and other countries followed suit. They all wanted to develop their own type of global positioning system. So the Russians called it the GLONASS. The Europe called it Galileo. Compass, Beidou by China, IRNSS by India, QZSS. So you see, people are trying to just show that they are powerful. Are you okay? The world's most powerful. Do you see any African country here? All right. So that's a question for all of us to think about. It shouldn't be about fufu and abenkwai all the time, okay, or jollof. We should also be creative. as these people have done. Is that okay? Which is challenge ourselves, change the status quo. Okay, so GPS, very powerful. What was it doing? What was GPS doing? When if someone had a GPS, one thing that he obtained with the device is a set of coordinates, longitude and latitude. Now, if you think longitude and latitude are nothing, go and watch a movie called Prison Break, and you realize that people were looking for a set of numbers, which were actually longitudes and latitudes, I presume. And so these special coordinates really allow someone to know where you are. Are you okay? And then when you watch a movie, yeah, I like movies a lot. I believe you also do. When you watch a movie and then they tell you that we know where you live. Are you okay? The killers in the movie, if they tell you that we know where you live, you know what I mean? They are coming to get you. So your location is so important. And that is what global positioning systems provided. And that is why the Uber driver can find you. Are you okay? Because they get to know your longitude and latitude. Okay. And that's because you have GPS in your phone, the GPS receiver. Is that okay? So GPS then becomes a precise positioning tool. It makes sense to say that. GPS is a precise positioning tool. So it could aid you to travel from one point to the other, because if I know where I am and I know where I want to get to, then I know where to steer, which directions to steer. So navigation, we're talking about air and then water, navigation, land, navigation, anywhere. Are you okay? On land, in the sea, and in the skies up there, we can navigate our worlds. Are you okay? Through these systems. So global positioning systems look at like this. If you look at this picture, a set of satellites that are going around, that have been launched into the skies, that go around in what we call orbits. Is that okay? So the orbits really allow, is like a path. Are you okay? It doesn't allow, it's a path that the so-called satellites, which are just really satellite panels and the actual structure that can really hang in the skies. Are you okay? Move in the skies for a long time, maybe some years, 3 years, 4 years, 10 years. Is all right. So on that satellite, you can put something there. Are you okay? And then what we put in there for GPS is the GPS transmitter. So we on the ground now receive a signal from these satellites, and then there's a calculation that is done. A message is sent to your phone. Are you okay? From about 2 or 3 satellites that allow your phone to now compute your position. That is how global positioning systems work. Simple as that. So you can see that these satellites, minimum of 24 going around in about 6 orbits, 4 in each orbit. Make sure that everybody, anywhere you are, and that's why we call it the global positioning system. Global means the whole globe. Anywhere you are, you can almost compute your location to some fair accuracy. Are you okay? So that's GPS for you. These are the receivers. So this is a handheld GPS. Normally not very, very accurate. Get an accuracy of about 10 meters to 30 meters thereabout. And then we have, this is actually a tripod mounted receiver. Okay, so these ones we can apply method differential GPS, certain methods to it that allow you to also receive very accurate positioning. Is that okay? So these are pictures that showing you exactly what the whole thing is about. Now this is an animation. If I were showing the PowerPoint itself, you see these points moving in a very interesting way, so that everywhere you are, you can obtain what? Your position. Is that okay? All right, so GPS has several segments. Is that okay? Before we talk about the segments, let's recognize that it can be used in weather forecasting, global climate studies. It can be used in earthquake analysis. If you want to know if some rock is moving small, you know, a little bit in bits, you can use GPS for that. Put a receiver there and observe it for a while, and then see, you know, the changes. Is that okay? We have people do a whole lot with it. Kayaking can be used for fun. Are you okay? Can have fun with GPS. Kayaking, you know, in Ghana, you don't see people. I think it's the Kwawu festival that people really kind of take part in. But Africans, we hardly do this kind of, you know, hiking. We hardly do that. It's like I'm going to the mountain to go and watch where the lions are. We hardly do that. But then it's all part of life, and GPS plays a very important role. When you sit on an aeroplane, we know exactly where the plane is via GPS. We can do that. So there's a GPS receiver in almost every device that we use. There are three segments. The user segment is the users, all the users. Okay, if you're in the plane, you're a user. If you're holding the phone, you're a user. If you are a surveyor, you're a user. We have a control segment that controls a constellation of satellites and make sure that they are in good health. Is that okay? And the health of the satellite is normally called the ephemeris, but that data is called ephemeris. Later, I think you can go into detail as in how GPS really work in what we call satellite surveying. Okay, we can have the space segment, which is actually made up of all the satellites out there. Is okay. So the control segment is made up of stations on the ground that are actually kind of monitoring and making sure these things are working all right. Okay, where exactly do we find this GPS satellites? Is okay. Where exactly do we find them? We find them at a distance of about 11,000 nautical miles above the earth, which is about 20,000 kilometers. Okay, so from Accra to Kumasi is about 200 kilometers. So you can use that to determine where you think these satellites are high up in the sky. Are you okay? But obviously, Accra to Kumasi is not that far when you compare it to Accra to London, isn't it? Okay, so it's relative, but definitely 20,000 kilometers is far. Okay, the radius of the Earth is also about 6,500 or so, 6,380 something kilometers. Is that okay? So you can also use it to compare with this one and see if you were to actually go around the world, okay, and if you were to actually go up in the sky by that same dimension. So 2 pi r square, okay, 2 pi r will be the circumference of the earth approximately. So that would be like 6 times 6, that's 36,000 thereabout. So if you were to go around the earth, you could almost reach where the satellites are. Okay, great. So that is GPS for you. Are you okay? For data acquisition. The last time I asked a question on data acquisition, most people pretended that they didn't even know that I talked about it in class. So I'm teaching you, I'm not forcing it on you. If you feel you're not flowing with it, you just have to tell me. But then I'm going to ask you questions on what I'm teaching you. Are you okay? And silence means consent. It's all right. Okay, no problems, guys, no qualms. So let's carry on. So we have more illustrations on the GPS. See the space segment, everything up here. The ground segment, I think there's one at Colorado Springs. That's one popular place where they have a GPS controller. Okay, the user segments. Okay, so we have the monitoring stations. All of that is the part of the control segment. Okay, right. In the orbits, etc. Okay, so GPS is very powerful, very useful, and we obtain longitude and latitude, which can be converted to XY coordinates. They work all around the world, so they call them the global positioning systems. Is that okay? All right. So you get a set of coordinates. Is that okay? All right. We'll talk about more projections later on. And remember when we get there, that these longitude and latitudes that we are talking about, they become relevant again. Okay, so the last primary data acquisition method that we talk about will be the remote sensing. The remote sensing is just like the photogrammetry. Is that okay? So the photogrammetry allows you to actually mount up sensors, which are just like the cameras. So instead of you mounting the camera on a plane or helicopter, biplane, helicopter, or drone, you rather have the sensor mounted on a satellite. Is that okay? So now you can distinguish between global positioning system and the remote sensing, in the sense that the remote sensing satellites are only sending data about their position, the position of the satellite, and then they are fixing your position on the ground. Okay, so you can imagine very precise calculation being done there. Okay, that's about positioning. What the remote sensing is doing is that it's only taking a picture of the earth, a portion of the earth from the skies. Simple as that. Okay, so we have some kind of scanner. The cameras are more like some scanners. Okay, they are more like scanners that actually scan the particular area of interest. Is that okay? All right, so that we can obtain an image of the area. Sometimes the remote sensing satellite can move all around the earth. Are you okay? It takes a path and it just takes a lot of pictures. It visits so many places on the earth and takes pictures of them. I remember when we were kids growing up, you know, there was a joke around that America can use their satellite to look at the bedroom of Muammar Gaddafi. Okay. And you see, it was the kids' own mindset of trying to understand how satellites work. Okay. Also, people actually, children used, you know, I don't know if today children have time for that, you know, look up in the sky and say, okay, that is a star, that is a satellite. Okay, the one that is blinking is the star, the one that isn't blinking is, you know. So all these were a bit to understand some of these things, even as children, without going to like secondary school crowd, and then people were talking about these things. All right, so we need to understand that the camera on the satellite, the remote sensing satellite, the remote sensing sensor on the satellite or remote sensing satellite, which is actually launched into the sky, can be tilted. Okay, when it's tilted, we have the off nadir. Okay, so here we say off nadir is up to 60 degrees. Is that okay? And a whole lot. How long can it stay up there? Dynamic range, bits per pixel, all that talks about the kind of image we are generating. Revisit time, how many times does it come to the same place to take a picture? Orbital altitude, how far is it? Are you okay? From the ground. This one is very near Earth, isn't it? 600 kilometers, 680, that is very low. Anyway, nodal crossing, yeah, satellites were launched by South Africa that were very small and they were also near the Earth. Okay, they were very close to the Earth. All right, we have nodal crossing, okay, all that. Some of them are not even we're talking about for now. We can have panchromatic, that's black and white, and then multispectral, that's colored, is okay, and then you can have infrared, near infrared. So the interesting thing about remote sensing is that you can determine, you can actually measure not only the visible light, you can also look at just the infrared. And you see infrared, you can't see the light. Infrared is what comes from your remote control. Is that okay? Mine just fell right now. When you take a remote control, there's no light that actually comes from the remote control. Is that okay? There's no light. When you press it, and in fact, I'm pressing it right now, just that there are no batteries. Sorry, I'm trying to deceive you here. But basically, you don't see any light, but there is light. Okay, so there are, when you actually take an X-ray, you don't see any light, but there is something moving. Okay, so that is what we call those energies that we cannot see. As for visible light, we can see it. As you can see me because there's visible light. Okay, reflecting off of me. So in remote sensing, we can not only measure from the visible portion of the so-called electromagnetic spectrum, but we can also measure from the other parts in mid-infrared, microwave, and all those ones. And mostly is the infrared, mid-infrared, far infrared, near infrared. Okay. So here you can see the near infrared is being measured. Okay. Now, so resolution also is referring to how how we can distinguish the objects. So spatial information, spatial resolution, I think I'm getting hungry, isn't it? Spatial information resolution is actually about how we can distinguish between the objects, while spectral range or spectral resolution really refers to the part of the electromagnetic spectrum that is being measured by the sensor. Remote sensing is very, very interesting. It's very, very, very interesting. There's always a source of radiation, normally the sun. The target is the ground, all the objects on the ground around you. The tank, polytank, the wall, everything, okay, the ground, bare ground, vegetation, all that is the target. Then there's the source of radiation, I've talked about that. Then there's the reflection of the source of radiation or the interaction of the radiation with the target now gets recorded in the sensor. Is that okay? All right. So we have what we call the active and passive sensors. Later we'll find out that at the airport they used to have something that they call the radar or so. They all kind of borrowed from this concept. Is that okay? So satellites can also, remote sensing satellites can also behave that way. Collection of data over large numbers of what wavelength bands, that's what I was talking about, can actually help you to determine the characteristic of an object. In other words, a satellite can pass during the night and determine where all the lions are. Simple as that. So that I rest my case. Don't want to talk too much about it, but that's how powerful remote sensing is. All right. It can measure from an area where we can't, easily do with our bare eyes. Is that okay? So this, in fact, this one, hyperspectral and multispectral, this is the reason why remote sensing is important. Okay. If someone did a research that actually informed us that trees sleep at night, it was because of some of these applications that were used. So apart from just recording the data into the sensor, the rest is analysis, being able to analyze the satellite data or imagery. Is that okay? It's an inexpensive way to obtain spatial information over a very large area. Because if you use remote sensing, you can map the whole Ghana very easily. But if you send surveyors out there to go and map, trust me, by 2051, they will still would have finished with Accra. Is that okay? It'll take a long time. And people that build houses and bought 4x4. So are you okay? All right. So it's very, very good. Remote sensing, a good data source. But let's understand how it works. Okay. So this picture tells you, this particular slide is about remote sensing and how it works. So look at it carefully. I've just talked about it, but I'll go over it again. There's an energy source, which is usually the sun. There's radiation and then through the atmosphere. There's an interaction with the target. Then the energy is recorded and transmitted to the ground. Are you okay? I think I didn't talk about that. Okay, so there's a transmission to the ground here. And then what again? Processing is done. Are you okay? Process the data, then you have to now interpret it. Just processing the data is good enough. Someone has to work with the data and say that, okay, this is what I see. I see the water levels here have gone down. That is another level altogether. That's the remote sensing expert who does that. And then, of course, you use it in a particular area. If you want to chew it, this is the formula for chewing. Okay, iritia. Easy, yeah. Energy source, radiation, interaction with targets, recording, transmission, interpretation and analysis of the data. Okay, guys, we have 10 minutes. If you have any question, get it ready. Okay, so here this a satellite image. So at the end of remote sensing, we obtain an image or a picture. Are you okay? And usually it's very nice. Let me just say, isn't it nice? This is some kind of stadium. Is okay, that has been captured. This can also be obtained using photogrammetry. Remember that. But the thing about remote sensing is that it can capture larger areas. Are you okay? Larger areas. Okay. So remote sensing is very, very powerful. Now look at this one. Site-specific identification of pathogen infestation. In fact, pathogens are disease-causing organisms, and think about it. We can actually use remote sensing to tell us, are you okay, what is happening with the infestation of a particular disease-causing organism. That's how important it can be. Is that all right? So remote sensing is very important. In fact, I think MPP has it in their manifesto. I'm not doing politics for MPP. Is that okay? I'm just saying that at least they have heard them talk about it, and it's good. MPP is always talking about some of these technologies. Is that okay? If you're an NDC person, don't get angry. I'm in charge. Okay. All right. So these are some of the things. This is another illustration of how remote sensing works. Okay. So the energy source is the sun. Then the sun shines its light. It comes down to the earth. Some of the data gets, absorbed, reflected, scattered, but eventually we get some into the satellite, which contains a sensor with several bands. Is that okay? All right. So that is the last, primary data source that I'm talking about. Any question, please make it ready, because the rest of it is that you buy. Are you okay? You buy the data. If you cannot collect the data, you buy it. Is that okay? You just buy it. Existing data, just go and buy it. Be okay. This is a little bit still more on the remote sensing. This is how pixels look like in an image. Are you okay? Yeah. So every single square contains just one color, etc. And then the color tells us what is there. Is that okay? All right. I know you're following. So if you cannot collect it using surveying, photogrammetry, GPS, or remote sensing, you just go and what? You buy it. Are you okay? Buy the hard copy. Are you okay? Go online, download it. But then you need to know the file types. Are you okay? Just don't go and buy data. You need to get the metadata. Those who didn't come for last week's lecture, you need to know the kind of data that you are being served with the attributes, entities, and attributes. Okay, so you need to appreciate these file extensions. Okay, if someone gives you data, you need to understand what kind of data are you giving me. Is that okay? So you get to know file extensions, DBF, database file, GANZIP file, compressed file. JPEG file is a picture file which is on our phone. Our phones have all the pictures we taken on our phones. Most of them are actually PNG. Is that okay? PRG is a projection file. We talk about these files, the so-called shape file. We will talk about the shape files. Okay, we talk about them. They are very a popular type of data set that is used in GIS. It's one of the most popular file formats in GIS. Is that okay? Then more compressed files are being shown over here. Yeah, compressed files. Okay, this is also a compressed file. Is that okay? It's said this also for raster. Are you okay? GeoTIFF is a georeference image. Georeference image has coordinates every part of the image, in every part of the image. Okay, the IT guys always try to do something with a map, but you can always catch them that they don't understand exactly what they are doing. Is that okay? But then a georeference image everywhere, we know what is there. Are you okay, guys? All right. So if you don't have any question, I think this is the end of it. And I think today we talked about a whole lot. We talked about concepts of GIS, and we've actually ended with data sources for GIS. Is that okay? The concepts of GIS that we touched on are topology, map overlay, okay? And we talk about buffering. Are you okay? Remember that these are the sort of things we talked about today. Concepts. Yeah, so that if you're asked an exam, mention one concept that don't say I don't even know which concept he's talking about. Yeah, buffering, topology, touch on map overlay, themes. Data can be organized in themes. We talked about data sources. We talked the concept of coordinates. You can compute coordinates, X, Y, Z coordinates. Okay. We talked about data sources. Data sources are land surveying. These are primary data sources. Secondary ones, you can buy them. We talked about global positioning systems. Touch or remote sensing. Touch or photogrammetry. Able to distinguish between these and find out which one will work in particular scenarios and which ones won't work. Are you okay? Most of the time, when there's a disaster, like I said, you don't want to use something like GPS or surveying. Are you okay? You want to use something like remote sensing or photogrammetry. Is that okay? And then there's advantage of using the remote sensing over the photogrammetry. Okay, because over large areas, remote sensing will beat photogrammetry. Ask any question. This is the second time, and I'm saying goodbye to you. If nobody has a question, I'll just say goodbye to you. If you have a question, put it up. I'm very happy to
Yeah.
answer the question. Yes.
Hello, sir.
Hello, go for it. I'm listening.
Yeah. Yeah. So I'm asking, in Ghana, can we provide our own GPS?
We can, but it's expensive. It's very expensive. You need to launch it. You need to launch it on the pad. Are you okay? A launching pad.
Yeah.
And if you Google it right now, how much does it cost to launch a satellite? In fact, you just it will baffle you. Are you okay?
Yeah.
Very expensive, and that is why we need to move away from poverty, and we need to find a way to really get out of that thing called poverty, because it's going to kill us eventually. The white people are just enriching themselves. Since slavery, they have just become better and better and better. We have just been, I don't know, standing still, marking time after colonialism and everything. So everything we're talking about, most of them are only possible if you have money. It helps a lot. It helps a lot. Nigeria has tried. I think they've tried to launch a satellite before. Are you okay? But in Ghana, we launched something, but we don't even know what happened with it. I think there was a university that did it, but maybe some grant or something. We haven't heard from anything at all that came out of that. Okay. You should also launch a satellite that will help you economically. Okay. You just don't launch any satellite out there.
Yeah, hello,
You
sir.
can do it. Yes.
Ye-
Yes.
Yes, I heard you saying it's very expensive,
Yes.
but civil engineering in principle way is very expensive. But when you use it for to get a common approach, that one does it helps more than that? As you are saying that it's very expensive because it's very expensive today. But in
Mhm.
terms of how it works,
Mhm. So what you are saying, what is your point? What's your point? Your point is that even though it's expensive, we should do it. Is that what you're saying?
so come again.
I don't get your question. Or is it a contribute? I don't know. What's the exact question? Anyway, this Zoom meeting is going to end now. It's going to end right now. Is that okay? So you can bring your question to the next class. Is
Yeah,
that okay?
I heard you saying it's very expensive.
Yes, I've put it there. Can you see it? $400 million. Do
I'll
you have
reserve
it?
it for the next class.
Can you
Yes,
see
yes,
it?
yes, yes.
$400
Yeah,
million.
yeah, I've seen it.
Uh-huh.
Yes,
So
yes.
so he